Hi, this is a presentation on the Introduction to Cryptography. Okay, so cryptology is from the Greek word hidden word. Cryptos hidden, logos word. Basically the science of secure communications. Cryptography is a branch of applied mathematics that concerns itself with taking some kind of plain text message and transforming it into some unintelligible form so that it cannot be viewed by unauthorized users, keeping it secret somehow. So cryptography is the process of converting plain text into something called ciphertext, unreadable text, using some kind of technique, some kind of method, or in today's cryptography methods, encryption. So encryption. Encryption is the process of changing the original text, which is we usually can think of it as plain text, readable text, into some secret message using cryptography. And as you can see here, there's some kind of key that's involved. We'll talk more about that in a moment. Decryption is reversing that process. So taking that encrypted text that we called ciphertext and using the same encryption algorithm, the same method, being able to reverse the process and then being able to view the plain text message. So there's something known as a key. A key is typically in today's world a mathematical value. It can be a word, a number, or a phrase that we enter in, and you'll see some examples of that coming up, that determines how you take the plain text message and how it is encrypted to create the ciphertext. It's the possession of this key that's required to also decrypt the message. So it both encrypts the message and also decrypts the message to recover the original plain text message. So key lengths. So you'll be, if you continue in investigating more about cryptography and encryption and that, you'll see that key lengths play an important part. Keys have this corresponding key lengths, which in cryptography we think is that, which is referenced as the number of bits, sometimes bytes, but we usually say number of bits in the keys. Key lengths today tend to be very large numbers. Larger the key length, the more secure. So key lengths can be 128, 256 bit longs or even longer. But longer the key length, more secure the ciphertext. Okay? But the other side of this means that it requires more processing, which means that there can be more of a delay in getting the information either encrypted or decrypted. So a couple of other terms. A cipher. Cipher is the algorithm for performing the encryption or decryption. A lot of times we just say encryption algorithm, and we use that same encryption algorithm or cipher is used for both encryption and decryption. And you're seeing here something called a shared key. We'll talk about keys in more detail in some later videos. But the cipher works with a key to generate the ciphertext from the plain text input. Okay, ciphertext is the data that has been encrypted. That's our secret that's taking the plain text data and creating some kind of unreadable text for it. Okay, so it's unreadable until it's been converted back into plain text, decrypted with a key. Now here it's showing a shared key, but that's not necessarily the case. Depends on the type of encryption method that we're using. And we'll talk more about that later, actually in another video on symmetric and asymmetric keys. So as far as cryptography, it's been around for quite some time. One of the earliest known ciphers was known as the Caesar cipher. It's actually what's known as a substitution cipher, in which each letter in plain text is shifted a certain number of places, key value down the alphabet. So for example, here you can see up above here, we have, if I can get my cursor, there you go, A through Z. If we decided to shift, if our key is 3, meaning we're going to shift by 3 places, okay, what becomes D is an A, what becomes E is a B, what becomes F is a C. We're just substituting the letters up above for the letters down below. Now you can see we have A through W, might be wondering what happened to the last 3 letters. They get moved over here. So A becomes X, B becomes Y, C becomes Z. So this is a very simple substitution cipher. Okay, it's a simple shift cipher, which means all you need to know basically is how many places to shift the alphabet, okay, to get from your clear text to your cipher text. Now you can see this may be not the most secure, because in the English language, there's only 26 letters in our alphabet. If we're including uppercase, we're just including all the same case, in this case, making everything uppercase. So which means we have exactly 26 mappings. So it's not very hard to decrypt this message. In fact, there's just 26 possibilities. So a more complicated or sophisticated way of doing a substitution cipher is to use something called the Veneer Cipher. So this came along several centuries later. So Veneer Cipher uses a 26 by 26 table in the English language. So you can see we have A through Z along the top here, different columns, and A through Z for the row headings. So both our column and row headings are A through Z. This is also known as a Veneer table here. So we can just see we have A through Z, then we have B starting at B, B through Z, then A. C says starting at C through Z, then A, B. So you can see that here in the row heading says which letter is it going to start with. So the Veneer cipher has, of course, the plain text message, but also requires a keyword or the key. So in this case here, our plain text is, this is a secret message. Our keyword is pass. Okay, something very simple, something very short, but it will help. Longer the keyword, generally the more secure and harder this is to break, but we'll talk about that in a moment. But we're going to keep it very simple, just keep it to 4 letters. Okay, so the keyword, as we're going to see, is repeated, so that it repeats for the total length equal to that of the plain text. What's that mean? Okay, so here we have our secret message, our plain text. This is a secret message. You can see the keyword is repeated above each letter of our plain text message. So we have PASS, then PASS again, PASS, PASS, PASS. So we just repeat for the total length of the plain text. So here we have kind of a short message. So how does this work? It's very simple. Okay. So what we do is we take our keyword, our P, the first letter in the keyword, which is P. Okay, so that's going to be along here. Here's our keyword. Then we take our first letter in our plain text message, which is T. And where those intersect is the cipher text, I. Okay, so I is our cipher text. So that will be now replaced with an I. Let's do the next 2 letters. Okay, we have A in our, so this number pass here. A is what we're using for our keyword, the letter in our keyword. H is now the letter that we're looking at in plain text. We're going to convert that, and actually, oddly enough, converts itself, not oddly, but it converts itself to the same letter H. Let's do the 3rd letter. We have S is the next letter in our keyword. I is the next letter in our message. So you can see how these just go column by column here. So those will be converted into a ciphertext of the letter A. Okay. Again, S is the next letter in our keyword again. S is also the letter in our message. K is the ciphertext letter. Okay. So I could do this all myself, but instead I want to also show you there's different programs you can just Google out there to do conversions of different types of ciphers. Caesar cipher you can do, Veneer Cipher. So let me show you what happens when we did the Veneer Cipher. So here's my plain text message. This is a secret message. I've chosen standard Veneer Cipher. Here's my key, my keyword or key is pass, and this would be the ciphertext. Now you may be thinking, wow, that's a great cipher. How can anybody break that? As a matter of fact, the number of possibilities are quite astounding. That given, you know, I forget how many, it's millions or trillions or even more possibilities. So it seems like it's almost unbreakable. However, the Veneer cipher and other substitution ciphers are susceptible to something called frequency analysis. Well, the good old, in this case, English language or any language, has some certain characteristics. Frequency analysis is the study of those characteristics, the study of letters or groups of letters contained in the ciphertext, an attempt to partially reveal the message. Helps us reveal the message, and from there you can start to figure out some of the other letters and groups of letters. Let me give you an example. So first of all, the English language and other languages as well have certain letters or groups of letters that appear in various frequencies. Matter of fact, the letter E is the most commonly used letter in the English language. And statistically, this chart here shows the statistically the possibility or the how each letter is most commonly used. The frequency is what I'm looking for, the frequency of each letter in the English language. So I saw that E is very common, so are the letters T, A, O. You know, if you've ever watched, what is that, Wheel of Fortune, you know, you notice that people are always saying, "Now give me an E," or "buy a vowel, take an E," or, you know, ask for a letter, say a T, because they know those are the most frequent, okay? But while there's other letters, Z, Q, and X, that are more rare. I think it's like the final part of Wheel of Fortune. They always throw some words in there that have some strange letters or less commonly used. And sometimes you'll see some of the contestants use one of these letters or a less commonly used letter, trying to think, okay, you're trying to, you know, make this hard on me. I'll choose a less commonly used letter. Okay, anyway. But there's also common pairs of letters, and even common you know, pairs, and even 3-4 letter combinations that are very common. And frequency analysis looks at these combinations. Okay, some of the most common pairs of letters in the English language are SS, EE, TT, FF. Okay, so although, you know, you can do this by hand, of course you can write a computer program. There's programs out there that will do this for you and do this process and show you how quickly, how this is done and how quickly even the Veneer cipher can be broken. The ciphertext can be broken using frequency analysis. There's a really nice video. I'm not going to go into it here, but if you're interested, I really suggest maybe watching this video or Googling or looking on YouTube for a similar video. But here's one called Cryptography, Breaking the Veneer Cipher. And it shows you how this is done with frequency analysis. So as far as modern cryptography, I'm going to talk about this in some of the other videos. Modern cryptography is the cornerstone of today's computer science and telecommunication security. So as you can see here in classical, we have substitution and transposition ciphers. In modern key-based, we have asymmetric and symmetric encryption. We're going to talk about those in the next video. But this is really all this modern key-based encryption is based on mathematics, using number theory, computational complexity theory, and probability theory. So there's some other videos. If you just look on YouTube for various videos on cryptography or Caesar cipher or any of these are some of the ones I just wanted to mention to you that I thought are pretty good. This guy's good. He talks a little fast for me, so you may want to slow that down. There's also this one here that gives you a little lesson on different block ciphers. And then always one of my favorites is anything to do on Crash Course Computer Science. And they have one on cryptography. And Kellyanne, she talks a little fast for me as well. And actually, I'm missing the letter here, so don't think that's either an O or, there we go, lowercase o. Okay, but just on YouTube, look for cryptography, Crash Course Computer Science. But again, she speaks a little fast for me as well, so I always have to slow these, go to the settings down here and slow them down a little bit. All right, so that's a little introduction to cryptography.